Special factoring techniques. Definition. A difference of squares of the form quantity ax squared minus quantity c squared will factor as the product of two binomials. The first binomial is ax plus c, and the second binomial is ax minus c. So how do I factor a difference of squares with the form a squared minus b squared? Well, first we look for perfect squares that multiply to be the first term, and look for perfect squares that multiply to be the last term. That is, often you can take the square root of the first and the last term. Put these factors into the blanks of a plus b quantity multiplied by the quantity a minus b. Notice that the sum of squares is not factorable. This is a difference of squares. We have subtraction. So I'm going to write in the corner a squared minus b squared because this is the form we want to look for. A squared minus b squared will factor as a plus b in parentheses and then a minus b in parentheses. So example 1, we have factor x squared minus 25. Well, I'm going to rewrite this as x squared minus 5 squared. So in this case, my a is x and my b is 5. So I can factor this as parentheses a plus b, well that would be x plus 5 in parentheses, and then x minus 5 in parentheses. Example 2, factor 36x squared minus 49. Well, I notice that this is two terms, and these are both perfect squares, so I can rewrite this as parentheses 6x, close parentheses, squared. 6x squared would be 36 squared, or 36x squared, minus 7 squared, because 7 squared is 49. So that this will factor as parentheses 6x plus 7, close parentheses, open parentheses, 6x minus 7. And the order doesn't matter. You can put minus first and then plus second as long as there's one of each. Example 3, factor 16x squared minus 81. Well, I can rewrite this as parentheses 4x, close parentheses, squared, minus 9 squared. And I'll also put the 9 in parentheses. So we can factor this as 4x plus 9 in parentheses, and then 4x minus 9 in parentheses. Theoretically, you could actually factor a difference of squares more than once. I don't think we have any examples like that, but be on the lookout that once you factor something, check to see that it can be factored more or not. Same thing we do with greatest common factors. Example 4, factor 24x squared minus 54. You might notice that these two terms are not perfect squares, 24 nor 54. However, we first look for a greatest common factor. And we have a greatest common factor of, let's see, 4 divides into 24, doesn't go into 54. So, see, 3 definitely divides into both of those. Something bigger than that. 6. 6 divides into both of these. So, greatest common factor is 6. So I can rewrite 24x squared minus 54 as 6 parentheses 4x squared minus 9. Well, 4x squared and 9 are perfect squares, so that this should be able to factor as 6, my two sets of parentheses. The first I'm going to have 2x plus 3, and the second 2x minus 3. Because 2x, that quantity squared would be 4x squared, and 3 squared would be 9. Example 5, factor negative 5x squared plus 20. Again, these are not perfect squares. However, I can factor out a greatest common factor. Put this over here. Of negative 5 because our first term is negative. So that I could write this as negative 5, open parentheses, x squared minus 4, close parentheses. Now, x squared and 4 are both perfect squares, so this can be factored as negative 5, that's our greatest common factor, and in our two parentheses we'll have x plus, or two sets of parentheses, we'll have x plus 2 and x minus 2. Again, because 2 squared is 4, and x squared is x squared. All right, example 6, factor 3x squared minus 75. These are not perfect squares, so we need to look for a greatest common factor. That's all we can do, and really the first thing we should always ask is, can we factor out a greatest common factor? There always is a greatest common factor. Remember, 1 always works, but we want something bigger than 1. So in this case, the greatest common factor is 3 between 3x squared and 75. So I can write this as 3 parentheses. That will become x squared minus 25. Well, x squared and 25 are both perfect squares. X squared minus 5 squared. So that this factors as 3 parentheses. X plus 5, close parentheses, open parentheses, x minus 5.